and it was concluded that by Thomas in 2011 that cracking was reduced in the presence of different SCM. In 2015, Afsini and Prosi concluded that presence of alumina, which is the amorphous of alumina, in SCM composition reduced the hydroxyl ion in concrete matrix uh, after its binding capacity of different alkalis. Kajmi discussed, Kajmi concluded that 40% replacement of sugarcane bagasse as with OPC reduced the expansion. Here we can see here in figure 2, this is figure 2, a control sample. This is control sample, this is 10%, 20 and 30, 40, and this is they have studied at 14 days here, and 14 days limit is 0.1 percentage, and 28 days, and 28 days ASTM limit was 0.2 percentage, and it was concluded that at 14 days SBA contained 20 to 14, like 20 to 40% of by weight of OPC, and it was concluded that the expansion was within the threshold limit, like uh, for these three graphs, and while for 28 days uh, the replacement of OPC with SBA up to 10 to 14 40% showed that the expansion was within the threshold value, that is 0.2 percentage. Here we can see here that this is the graph for expansion at 28 days of SBA incorporated concrete, and this is for control sample. For abrasion resistance, Rashad developed the high volume fly ash concrete, and it was concluded that silica fume alone or combined with GGBS showed higher abrasion resistance, like we can see here in figure 1 by enlarging it. This is wear depth. We can see here this is wear depth. This is for control. This is for uh, like fly ash, 70% fly ash, and uh, this is for 50% fly ash and 20% silica fume, and this is for 60% fly ash, 10% silica fume, and this is for 70% of fly ash. So we can see here that wear depth was reduced uh, after incorporating SCM materials. While reverse trend was followed, while the lowest abrasion resistance was observed for GGBS incorporated high volume fly ash concrete. Now further, three authors, Rashad in 2013, Naik in 2002, and Yen in 2007, conclusively uh, inferred the outcome that curve between compressive strength and resistance to abrasion showed the linear relationship. Although in the recent year, a few authors showed that this curve can show the parabolic relationship also. That is non-linear relationship also. So basically, it depends on the mix proportions and the type of curing and the amount of SCM materials added, and the water cement ratio also. Uh, so basically, it is the function of different input variables. According to that, output in the form of different properties, attributes like compressive resistance to abrasion will be takes place. In 2018, Jamaluddin concluded that abrasion resistance was increased by 10.4 and 23.6% than that of controlled concrete at 28 and 91 days, and which was due to microfiller effect of RHA. So here we can see that that this is for control concrete. This is for non-processed RHA, and this is for grinded RHA, 5 minute, and this is for mm, rice husk ash grinded at 8 up to 8 minute grinding takes place, and it was concluded that weight loss was decreased as the fineness of RHA was increased from top to bottom. Similarly, for 91 days also. Regarding acid resistance, Murthy and Shivkumar uh, uh, concluded that ternary blend developed using 20% fly ash and 8% silica fume showed better resistance to acid compared to that of binary blended or normal concrete. Uh, Budia et al. In 2010 showed that, as shown in figure 1 and 2, that percentage mass change and compressive strength. Figure 1 is related with mass change percentage, and figure 2 is related with compressive strength. And uh, at different fineness, different particle passing like 45 micron, 10 micron. This is for 10 micron, this is for 45 micron, and this is for control concrete. So it was concluded that acid resistance was increased uh, um, uh, by increasing the fineness of palm oil fuel ash, and also concrete for concrete compressive strength in acid curing. The compressive strength was more for POFA 10. And a similar conclusion was also made by Newman and Chu in 2003. Uh, and they have concluded that other SCM such as metakaolin, GGBS, RHA showed the similar kind of relationship and behavior. Regarding fire resistance, Ju in 2001 concluded that compressive strength of concrete was increased beyond 250 degrees centigrade because um, as the as we know that as the uh, temperature of curing in case of concrete increases, the formation of more hydration product takes place like CSH and CSH etc. And therefore further hydration takes place beyond 250 degrees centigrade, but it is up to a limit, not like that at 800 degrees centigrade the compressive strength will be more and more as we increase the temperature. So there is limit, not like that we have to increase the temperature and we will get more and more strength. And second conclusion was that durability loss was observed due to weakening of ITZ at the same time caused by fire exposure. In 2003, Newman and Shu used silica fume, and they have concluded that fire resistance was more for ultra high strength silica fume concrete. Um, uh, uh, for controlled sample, but for ultra high strength silica fume concrete, the fire resistance was less because silica fume is was very fine, and which decreases the permeability of concrete too much, and due to which steam pressure, vapor pressure can't escape. Therefore, spalling occurs for ultra high strength silica fume concrete. In 2003, Pune et al. Concluded that compressive strength was increased till 200 degrees centigrade. Here, Zuel et al. Also concluded similar kind of finding that compressive strength was increased only up to 280 290 degrees centigrade. And also strength and durability loss was more than that of more for metakaolin concrete than that of silica fume fly ash and OPC concrete at elevated temperature. Regarding efflorescence, Ambrose et al. Uh, Smith and Newman Chu concluded that the efflorescence was reduced because the calcium hydroxide